10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everyone, this is again Professor Vincent Torre Bongolan, and in this video, I will walk you through how to construct the frequency distribution table. Alright, so if you want to know the preliminary steps on in constructing a frequency distribution, go to the description part of this video so you can go to the part 1. Alright, so this is the part 2.
Oh, namumula ka na.
Hello everyone, so I am here now at my condominium unit in Cubao, and I would like to do a quick demo of the Internet of Things and the AI application that is developed for my condominium unit.
What is Digital Week?
The Digital Week 2019 is an ADB annual.
Alright, so a frequency distribution table is a well-defined and explained frequency distribution table consists of the following components or columns. Alright, so the first components or parts of a frequency distribution table is the class interval or the class limit. The researcher or the analyst must consider the manner of measurements when setting up the intervals. Start by identifying the lowest score and consider it as your first lower class limit. Then add up the computed class width to the first lower class limit. Include the lower class limit as your starting point. Do this successively until you reach the interval where the highest score belongs. Alright, so this is how to do the class interval. Alright, so remember that the lowest value in the distribution is 39. And based on the step C that we conducted in previous part, which is part 1 of a frequency distribution table, the class width is 174. Alright, so add 174 to 39, we will get 213. And for us to be able to calculate or to compute for the class interval for the second limit or the second class, we need to add 1 from 213 to avoid encroachment between each class. Alright, so 214 again plus 174, we will get 388. And then 388 plus 1, it's 389. 389 plus 174, that would be 563. 563 plus 1, 564. And then 564 plus 174, we will be getting 738. And 739 plus 174, we will be getting 913. Alright, so remember, the class width is 174. Alright, so the class width is 174. Alright. The second component is the tally or the frequency. This is the count of observation under each of the class intervals. Alright, so for the class interval of 039 to 213, there are 50 individuals or records. Alright, so for 214 to 388, there are 43 records. For 389 to 563, there are 9 records. 464 to 738, there are 5 records. And for the 739 to 913, there are 3 records. Alright, so that is the second component, the frequency. The third component of the frequency distribution table is the midpoint or the class mark. So remember, during the first video, class mark is denoted by symbol X, or sometimes it was denoted as M. Alright, so how to do the midpoint? So simply get the average of the class interval. So 039 plus 213 divided by 2 is 126. 214 plus 388 is divided by 2 is 301. 389 plus 563 divided by 2, it's 476. 564 plus 738 is equal to 651. 739 plus 913 divided by 2, it's 826. Alright, so technically, a class midpoint is defined as the point halfway between the class limit or the class boundaries. It's called the class mark or the midpoint. Alright, so this is simply the average between the upper class limit and the lower class limit. The fourth component is the cumulative frequency. So we will need to calculate first the less than cumulative frequency. So determine the cumulative frequency by getting the frequency of the lower class and add it successively to the frequency of the other class. So remember, in class 1, the minimum value is 39. So what's the frequency in the class interval of 039 to 213? So we will need to copy 50 to the less than cumulative frequency. And 50 plus 43 is 93. 93 plus 9 is 102. 102 plus 5 is 107. And 107 plus 3 is 110. Alright, so the fifth component is simply the opposite of the less than cumulative frequency. This is the greater than cumulative frequency. So we need to start at the bottom part of the table. Okay, so we will copy the frequency of the class 5, which is 3. 3 plus 5 is equal to 8. 8 plus 9 is 17. 17 plus 43 is 60. And 60 plus 50 is 110. So that's the greater than cumulative frequency. And the sixth component is the relative frequency distribution. Alright, so the relative frequency distribution is simply the ratio of the number of observations in the class interval to the total number of observations, known as the relative frequency. The percentage frequency distribution, on the other hand, is arrived by multiplying the relative frequency distribution by 100. Alright, so to calculate the relative frequency distribution, that's we need to get the 50 divided by 110. We will be getting 0.45. 43 divided by 110, we will be getting 0.39, and so on and so forth. So we need to divide the frequency by 110. So in order for us to calculate the relative frequency distribution. Alright, so the percentage frequency distribution, all we need to do is to multiply the RFD by 100. So to add the PFD, it should be 100. Alright, so this is the frequency distribution table. Thank you.